Have you ever wondered about the most mysterious aspect of your existence? It's not space or matter, but the invisible current that carries you from one moment to the next: time. Time's most defining trait is its unwavering directionality, a one-way journey from past to future, what physicists call the arrow of time. Unlike space, where you can revisit places, you can never return to yesterday. This simple truth reveals a profound divide between the world described by physics and the world we experience. In this journey, we'll explore why time has a preferred direction, how it shapes our universe, and why understanding it is key to grasping the very fabric of reality. At the heart of the arrow of time lies a paradox, a deep and perplexing question that challenges our fundamental understanding of the universe. It's a riddle wrapped in an enigma, shrouded in the very fabric of existence. We perceive time as relentlessly marching forward, an unstoppable current carrying us from past to future. But what dictates this direction? What makes the past different from the future? The microscopic laws of physics, the very equations that govern the behavior of particles at the smallest scales, are time-symmetric. This means that, theoretically, these laws work equally well whether time is moving forward or backward. Imagine watching a movie of subatomic particles interacting. You wouldn't be able to tell if the film was being played in reverse. But our everyday world is not time-symmetric. We experience a clear and undeniable directionality to time. Watch two billiard balls collide on a pool table. The impact sends them scattering, a seemingly simple event. Now run the film backward. The balls converge, perfectly striking each other and coming to a stop. It looks just as plausible, doesn't it? The laws of physics don't forbid this reversed scenario, but a shattered teacup reassembling itself from broken shards on the floor, spontaneously leaping back onto the table, instantly impossible. Our intuition screams that this is a violation of the natural order. The fundamental laws of physics allow reversibility. They don't inherently dictate a direction for time. But the universe's starting conditions, the state in which it was born, do not allow for such symmetry. The initial state of the universe was incredibly special. The Big Bang, the event that birthed our cosmos, began in a state of extraordinary order, a state of remarkably low entropy. This means that everything was incredibly uniform and organized in the early universe. Since then, the universe has been on a one-way journey, an inexorable slide down the entropic hill, toward increasing disorder, toward greater randomness and complexity. This increase in entropy is what defines the arrow of time. The arrow of time emerges not from the laws themselves, the fundamental rules that govern the universe, but from the universe's improbable beginning, from that initial state of incredibly low entropy. It's a consequence of the Big Bang's unique starting point. That's why we see eggs scramble in a pan, the yolk and white mixing together in an irreversible process, but never unscramble, never spontaneously separating back into their original components, and why the universe on a grander scale moves from order to chaos, from simplicity to complexity. The direction of time, therefore, is a game of overwhelming probability, a statistical certainty driven by the sheer number of possible disordered states. It's not an absolute prohibition, not a law etched in stone, but rather a deeply ingrained tendency, a cosmic bias towards disorder. The psychological arrow of time is the most personal. Our minds only remember the past, never the future. We accumulate memories of what has happened, but can't recall what's to come. Our sense of agency points only forward. We can change tomorrow, not yesterday. This asymmetry shapes how we plan, learn, and feel regret or hope. Memory formation itself is a physical process that increases entropy, tying our mental arrow to the thermodynamic one. Even our perception of time is shaped by culture and language, but the underlying direction remains. The psychological arrow is a complex interplay of cognition, language, and physics. It's the arrow we live by, defining our experience of reality. The thermodynamic arrow, a concept born from the depths of physics, is the most robust explanation we have for the direction of time. It's not just a theory. It's a fundamental principle that governs the behavior of the universe itself, dictating how things change and evolve over time. It's rooted deeply in the second law of thermodynamics, a cornerstone of modern science that describes the tendency of systems to move towards disorder. This law isn't just some abstract idea. It's a tangible force that shapes everything around us. In essence, entropy, a measure of disorder, always increases in an isolated system. This means that, left to its own devices, any closed system will naturally progress towards a state of greater randomness and disorganization. This fundamental law drives the universe from a state of order to one of increasing chaos. a relentless and unstoppable process that defines the very nature of time's passage. It's a one-way street with no turning back. Think of it like a sandcastle meticulously built on the beach, destined to inevitably crumble back into a formless pile of sand, washed away by the relentless tide. Everyday irreversibility, the things that happen and can't be undone, like an ice cube melting into a puddle of water, or smoke dispersing into the air, never to be gathered again, or milk mixing into coffee, creating a homogeneous blend that can't be easily separated. All of these phenomena faithfully follow this fundamental rule of increasing entropy. The sheer number of ways for things to be disordered, for things to be in a state of chaos, vastly outweighs the limited number of ways for them to be perfectly ordered and neatly arranged. The thermodynamic arrow isn't about absolute impossibility. It's not saying that order can never spontaneously arise. Instead, it highlights the overwhelming probability that disorder will prevail. The universe, in its grand and relentless march forward, inevitably moves toward the most statistically likely state, a state of ever-increasing entropy and greater disorder. This statistical certainty, this unwavering tendency towards chaos, is what ultimately gives time its perceived direction at the macroscopic level, the level at which we experience the world. Every broken egg, its contents splattered and irretrievable, and every faded photograph, its colors bleached by the passage of time, serves as a poignant testament to entropy's relentless march, a constant reminder of the universe's irreversible journey towards disorder. The cosmological arrow of time is defined by the universe's expansion since the Big Bang. As space stretches, galaxies recede, and the future is the direction in which the universe grows. This expansion allows entropy to increase, intertwining the cosmological and thermodynamic arrows. If the universe were static, it would quickly reach equilibrium and stagnate. Expansion keeps complexity possible. Current evidence suggests the universe will expand forever, leading to a cold, empty fate, the Big Chill. The cosmological arrow not only defines our present, but also our universe's ultimate destiny. The radiative arrow describes how waves like ripples in a pond or light from a star always spread outward, never inward. This is another face of the thermodynamic arrow. Outward spreading waves are more disordered and probable than perfectly converging ones. The causal arrow is just as fundamental. Causes precede effects. We strike a match, then it ignites. This ordering of events underpins logic, reason, and our ability to act. Both arrows are rooted in entropy. Making something happen increases disorder. The universe's preference for higher entropy ensures that we can influence the future, but never the past. The radiative and causal arrows are everyday manifestations of time's irreversible flow. In quantum mechanics, the core equations are time-symmetric, but measurement introduces irreversibility. The wave function evolves smoothly until observed, then it collapses into a single outcome, and there's no going back. This quantum arrow of time is linked to thermodynamics through decoherence. Interaction with the environment scrambles quantum information, increasing entropy. Recent quantum computing experiments have even reversed this arrow for isolated qubits, but only under highly controlled, low-entropy conditions. The quantum arrow isn't absolute, but its connection to entropy is clear. At the smallest scales, time's direction is still shaped by the universe's march toward disorder. Even in the quantum world, irreversibility emerges from the same fundamental principle. The particle physics arrow is the most subtle, revealing a true asymmetry in nature. Most laws are time-symmetric, but certain weak nuclear force interactions violate this symmetry. This T-symmetry violation, first seen in kaon decay, shows that nature itself has a preferred direction for time. This tiny asymmetry may explain why the universe contains more matter than antimatter. Without it, matter and antimatter would have annihilated, leaving only radiation. The particle physics arrow is a fundamental crack in time's mirror, making our existence possible. We've followed time's arrow, that invisible yet ever-present force that dictates the unfolding of events. It's a concept that has captivated thinkers for centuries, a fundamental aspect of our universe that shapes everything from the smallest particle to the largest galaxy. From our minds, where memories fade and thoughts evolve, to the cosmos, where stars are born and die in a grand cosmic dance. The arrow of time is not just a scientific concept, it's woven into the very fabric of our existence. In our exploration, we keep discovering a collection of interconnected arrows, each pointing in the same direction, each contributing to the overall flow of time. These arrows manifest in various forms, from the decay of radioactive elements to the growth of a tree. They are all pointing relentlessly from past to future, a one-way street with no turning back. This directionality is what gives time its unique character. distinguishing it from space, where we can move freely in any direction. Most are emergent, arising from the collective behavior of countless particles and interactions. These emergent arrows are not fundamental laws of physics, but rather consequences of the underlying laws and the initial conditions of the universe. They are driven by the master arrow of thermodynamics, the principle that entropy, or disorder, always increases in a closed system. This relentless increase in entropy is what dictates the flow of time, ensuring that the past is always different from the future. And it all began with the universe's improbable beginning, a state of incredibly low entropy that set the stage for the unfolding of cosmic history. The Big Bang, with its initial conditions, is the ultimate source of time's arrow. This arrow bridges the gap, connecting the microscopic world of particles with the macroscopic world of our everyday experience. It's the link between the fundamental laws of physics and the phenomena we observe around us. It reconciles the reversible laws of physics, which suggest that time could flow in either direction, with our irreversible experience, where events unfold in a specific sequence. We remember the past, but we cannot remember the future. It is shaping causality, the principle that cause precedes effect, ensuring that events unfold in a logical and predictable manner. Without the arrow of time, there would be no cause and effect, no order in the universe. It is also shaping complexity, the emergence of intricate structures and patterns from simple building blocks, and ultimately meaning, our ability to make sense of the world around us and find purpose in our lives. The arrow of time is central to science, providing the framework for understanding the evolution of the universe, the behavior of matter, and the nature of life itself. It is a cornerstone of our scientific understanding of the world, and it is also central to philosophy, raising profound questions about the nature of reality, the existence of free will, and the meaning of existence. It challenges us to think deeply about our place in the cosmos. It is defining our sense of self, our awareness of being a continuous entity that exists through time, with memories of the past and hopes for the future. Our identity is inextricably linked to the arrow of time, and it is defining the narrative of existence, the story of the universe unfolding from the Big Bang to the present day, a story in which we are all characters. We are all part of this grand cosmic narrative. It reminds us that moments are fleeting, precious, and irreplaceable, and that we should cherish each one as it passes. Time is a gift, and we should make the most of it. And it reminds us that the past cannot be changed, that we must learn from our mistakes and move forward with wisdom and compassion. The past is a valuable teacher, but we cannot dwell on it forever. The quest to understand time's arrow is not just a scientific endeavor, it's a deeply human one, driven by our innate curiosity and our desire to make sense of the world around us. It's a journey of discovery that has been going on for centuries. It is a quest to understand reality itself, to unravel the mysteries of the universe and our place within it. It's a quest that may never be fully completed, but the pursuit is what matters. As we seek deeper answers, pushing the boundaries of knowledge and exploring the unknown, we are guided by the arrow of time, that unwavering force that propels us forward. The arrow points the way forward, illuminating the path towards a greater understanding of ourselves and the universe we inhabit. It is a beacon of hope, guiding us towards a brighter future. It points the way forward for science, inspiring new discoveries and innovations, and for us all, offering a framework for living a meaningful and fulfilling life. It is the key to unlocking our full potential as individuals and as a species.